Yeah, I want to talk about what one-to-one functions are as well as onto functions. So, in the previous video, we talked about what functions are. And in general, there are these vertical and horizontal line tests that I'm going to discuss. So, a vertical line test is to tell whether or not something is indeed a function. We talked earlier about what a function is, and it states that every value in the domain, so we see here's a value in the domain, has exactly one output. So notice here is one x coordinate along this circle here, right? This is one x coordinate. And there are two y values for that x coordinate. This circle is not a function because it fails the vertical line test. It hits here and here. This is a function over here because we see that there's only one point along all of this function where it hits a vertical line. In other words, there is exactly one value in the codomain there for every input. Let's see if I can show some other examples. This is an example of a function because uh, it only hits one point. Here's an example of not a function because it hits two. This is an example of not a function as well, and in fact it hits 3 points. This is a function over here. So this is the vertical line test to tell whether or not something is a function. Now this is known as the horizontal line test. Now this horizontal line test will relate to one-to-one functions. So a function is said to be one-to-one or injective if for every two elements x sub 1 and x sub 2 in the domain, if f of x sub 1 equals f of x sub 2, then x sub 1 equals x sub 2. Now, I personally would not memorize this definition. You know, there are different ways to actually define this thing. This is an easy way of defining it is there exists exactly one value, if you notice this. But rather, understand, so the way I kind of memorize this is that we see that there is a dash on one-to-one, right? And if we look at this dash, I always think this is the horizontal line. So when I think one-to-one, I think of this dash and I see this horizontal line right here. And I think, well, does this pass the horizontal line test? So if a function passes the horizontal line test, then this function is one-to-one. So, and we can explain what this means in relation to this over here. So here's an example of a function right here. And we see that here are two values, f of x sub 1 and f of x sub 2. They are equal to each other. They are two different x coordinates though, however. Now, this is saying this is not a one-to-one function because since these values both have the same y coordinates, they should have the same x coordinate. And we see that this over here fails the horizontal line test because here's one y coordinate, but it hits here and here. It hits multiple x values. So it fails it. This one over here passes the horizontal line test, which means it's one-to-one. So let's talk about this one over here. Let's just think about this one conceptually. Is the function f, 3, 5, 4, 3, 2, 5, is that function one-to-one? So if we think about that for a second, well, we see two y coordinates that are the same, right? We see two y coordinates that are the same. And then they have two different x coordinates. So no, this function is not one-to-one for that reason. These values should be the same for the x coordinates if they are both 5 over here. Which function is one-to-one and which one isn't below? So let's talk about this one here. Well, here all of the y values, there is exactly one way back. We see that. And if we think about this one over here, here's a y coordinate. and this one is sent to multiple regions back. So this one over here is not 1-to-1. This one is 1-to-1. So for the answer for this one is 1-to-1, and option 2 is not 1-to-1 for that exact reason. Now it's also a function is said to be onto or surjective if the codomain and range are equal. Now, I haven't really seen the definition written like this, except in your textbook it is written like this, which I kind of like. An alternative definition that can quite easily be proven equivalent to this is that for every value y in the codomain, there exists an x in the domain such that f of x equals y. So let's talk about this, what this means for onto or surjective functions. So this example over here is an onto function because every value y in the codomain, this is the codomain, this is the domain. So this is the codomain. There exists an x such that it's sent over to it. So let's look at this one over here. Here's a value y. Here's a value y in the codomain. There exists an x in the domain such that f of a equals 1. So that 1 is good. But let's look at 3. 3 is causing problems. So here's a value y in the codomain. There should exist a value x such that f of x equals y, and it doesn't. So for that reason, this is not an onto function. And in other words, the codomain, this is my codomain, should be the range. The range we know is 1, 2, 4. And that's another way of looking at it. So this one is over here. We know that there is one way, that there is a value that in the domain that sends it over. And this one is not because the codomain and the range are not equal. So hopefully that helps. Here's some other examples of that I can think of as, to clarify whether or not something is 1-to-1. I know we were talking about onto functions earlier, but let's talk about something that looks like, let's give it some roots. All right, well, let's look at this. Is this function here 1-to-1? So when we think about 1-to-1 functions, well, 1-to-1 functions have to pass the horizontal line test. Well, I can draw a horizontal line here, and it hits 2 values, so this function would not be 1-to-1. Let's say something looks like this. Would this be 1-to-1? And the answer again is no. I mean, we can draw a horizontal line where it hits here, here, and here. So it would not be 1-to-1 because it fails the horizontal line test. Other example of a function. Let's say it looks like this. Would this function be 1-to-1? And this function would be 1-to-1 because every horizontal line throughout this whole thing hits exactly once. So it would be 1-to-1. All right, let's talk about this. Would this be onto? Now, so since we're talking about onto, well, we need to figure out what is the codomain and what is the range to even consider this. Now, your book says that the codomain is assumed to be, it doesn't say this specifically, but the codomain is assumed to be all real numbers. And here, the range, well, we see the range is 0. It includes 0 all the way up to infinity. Now, since the codomain all real numbers does not match that of the range, they are not equal sets, we would say that this function here is not onto. And I understand that's quite confusing because they don't explain what the codomain is, and they really should, but that's the explanation behind it. I hope this video helped.